more so that Python is, well, he will talk more about Python. So I'll leave it over to him. We know we're in good hands. Right. Over.
All right, thank you to everyone who is here for this presentation. The topic of our presentation is data science with Python. We are going to be doing practical demonstration of this. So there are 3 categories of people who will benefit from this presentation. The first are people who wish to be data scientists, but don't know how to forge ahead with the career path. This presentation will expose you to what the data science workflow is all about, and they expose you to the tools and skills you need to acquire to be able to do well as a data scientist. The second category of people are people who are data analysts or data scientists, please, and but they are at the early stage of their career. They've not seen the end-to-end implementation of a data science project. We are going to follow through with data science workflow and implement a real-world project that will be deployed finally in a web application using Streamlit. So that will make you see firsthand what a data science project is all about. The third category of people are people who are not interested in technical skills. They don't want to be IT personnel, they don't want to know how to code. But they are entrepreneurs. They have data. They would like to, get people to analyze for them. Or they could be project managers who have people working under them. And amongst these people, experts who work under them are data scientists. So this presentation will enable them to see what data science is all about and the job a data scientist could be doing under him. Because I believe understanding this, you can't manage people you don't know what they are doing. So this will expose you to understanding what data science is and how to improve your project management skills when it involves a data scientist. So first of all, before we go to the practical demonstrations,
we're going to.
Hello.
Please, can we all mute ourselves, please? Can we just mute everybody to allow the speaker to continue? Apologies, Dr. Chinedu.
Okay, so I thought maybe something went wrong. Maybe the screen is not being shared. I hope everything is all right, okay? All right, so we'll first of all, before we go into the practical demonstrations, we'll first of all introduce ourselves to what data science is all about. Then we talk a little bit about modeling, including machine learning or data-driven models. Then we talk about the toolboxes that are used for data science. And then we narrow down to the libraries in Python that we'll be demonstrating today. And then we go into the practical demonstrations. So data science is a field of study that leverages tools like mathematics, machine learning, computer science, statistics, and others in deriving knowledge or value from data. And what fuels the interest in data science today is because we have humongous amounts of data available in our space. And this is what drives the concept of big data. So big data has been explained using 5 dimensions, what we call the 5 V's of big data. The most intuitive of all of them is volume. That's what everyone thinks about when you mention big data. They think about how big the data is. So volume has to do with the large amount of data in our space. For example, Facebook has been reported to see up to 4 petabytes of data every day. 4 petabytes, 1 petabyte is equivalent to 1 million gigabytes. So if you know what a gigabyte is, you should be able to imagine how big a petabyte is. And that is what Facebook sees in a day. Then another thing is the velocity of data. Data changes so quickly. If you go to maybe Twitter and you look at the trending topics, the hot topics, in 5 minutes, these topics will change, which means things are changing so quickly, and data represents this change. And if we want to rely on manual processing to be able to get values from this data, is going to be difficult. So the need for a conceptual, a systematic framework that will enable us keep track of these changes is very important. Then another dimension of big data, one of the 5 V's, is variety. We have data in different forms. We have data in form of text. We have data in form of images, in form of numerical values. We have data in different forms. And so this also represents a dimension of big data. Then there is value in data. Data could help a business to plan, to budget, to design programs, market programs that will suit their customers. There is also veracity in data. We have data, some of the data we have, data is hybridized with both accurate and inaccurate data. So we have issues of fake news on our social media today. And how can we know that this particular data represents the accurate data? So this is also a dimension to big data. And that is one of the things that data science comes to handle, to be able to address these key 5 needs. So there are different sources of data, as we've mentioned, from surveys, some businesses rely on surveys. Some get data from social media, some rely on mobile phones data, some rely on transactional data, on the transactional data basis. We could have data from sensors and maybe from satellites. So these are different sources of data that a data scientist could analyze. But data is not always a darling. It's not always as innocent as we want it. Okay, so when you want to go into data science, you think you'll be managing data that is so small, that is well structured in a tabular form, numerical values, no noise, that is so clean to be worked with. But in real life, that is not always the case. We see data that is very big to handle. We see unstructured data that are not just numerical values. They are text, some of them are images, and we are meant to get values from this data. Some of them are noisy. Okay, some of the vital points, the important things in this data could be missing, and we want to be able to cope with this kind of data. The only field that helps us to handle this kind of scenario is data science. And that is why we study, or data science is important. So there has been this debate about data analysis and data science. Some people talked about, say, I have had a lot of people ask me the difference between being a data analyst and being a data scientist. And this argument is not closed yet, so a lot of people have different views about it. So I'm going to tell you my view about data analysis and data science, and that will make us drive home why data science is very important. Data analysis provides answers to already defined questions. This question is already well defined. A business owns a database, and they want you as a data analyst to tell them their items that were mostly sold or that was mostly sold during COVID-19 lockdown. This is a very direct question, which is easy to answer by maybe querying the database or plotting your graphs. You are able to see these things. So what data analysis provides is answers to a well-defined question. But data science does something different. What data science is capable of raising unexpected findings, things you never expected that they were there in your database. For example, there is this popular example about beer and diapers correlation in the data science literature. So before I talk about this beer and diapers correlation, I'm going to talk about something very important that will make us understand the beer and diapers correlation example. Okay, and this is what we call market basket analysis. If you have used an e-commerce platform such as Amazon or Jumia or eBay, they have what is called a recommender system. What the recommender system does is to recommend items you could be interested in. You buy maybe item A, the recommender system tells you that those that buy item A often buy item B. You buy a phone, a mobile phone, the recommender system tells you that those that buy phones always buy headsets. So they find out items that you may be interested in for buying a particular item. This is what is called market basket analysis. And how does this recommender systems do this? They look at the basket of people that shop in that particular platform. When we talk about basket, we talk about what people buy at a go. When for one shopping, what they buy at a go, that is called a basket. So they look at the baskets of people that have shopped on the website, and they're able to find out association between items. People in the recommender system, we call it item collaborative filtering. So they find out the relationships between these items, and based on these relationships, these algorithms are capable of recommending things you would like if you buy a particular item. Now, this is called market basket analysis. A particular shop decided to do this kind of analysis on their items. And one of the reasons why a shop may want to do such a thing is so that they can arrange their items in a shelf in such a way that closer items, shelves, where items that are associated are, will be closed. So that when you want to buy a phone, you will remember that you needed a high headset and you buy it at once. So when this supermarket did this kind of analysis, something unexpected happened. They discovered that beer and diapers have an association. They are always in the same basket. So this is unexpected. There is no one that would have posed this kind of question, to a data analyst. So when this happened, it became a very confusing scenario, because the question could be, does it mean that babies also drink beer or something like that? So it was really confusing. But they now went deeper to drill into the database to find out what actually resulted to this association. When they went to the database, they discovered that this kind of basket exists mostly in the evening time. Now they went deeper to find out what really happened. Why is this association? They now found out that this association, this kind of basket, has to do with young fathers. And what happened was that some of the young fathers, when they are coming back from their work, their wives could call them that the baby's diaper has finished. So when they went to the supermarket to buy the diaper, they discovered that they needed some beer. They bought it. So that is how these two things managed to be in the same basket, right? So it is only data science that is capable of uncovering such relationship that is very latent relationship. Now, we talk about data science workflow. When we talk about workflow, we talk about the different phases that are followed in executing a project. That is what we mean by workflow. So there are different workflow, or what we call data science project lifecycle, or data science process model that people follow in realizing a data science project. One of the most popular one is what we call the cross-industry standard process for data mining, or the CRISP-DM. So we are going to explain this now. If you look at it, we can see that we have, I'm going to get my laser pointer. So we have data at the center of this. So which means if there is no data, there is no data science. Data science depends on data. Now, what is the first thing we need to do? Assuming that a company calls us as a consultant, data science consultant, to help them learn something from their data. The first thing we need is what is called domain knowledge. We want to understand the operations of that particular business. What are they into? Why are they getting this data? What is this data all about? What is the source of this data? So we need to understand from the business point of view how they understand data. We need to understand their data pipeline. From where is this data coming out? How do you store your data from the business point of view? Now, when we are done understanding the business, we move into what we call data understanding. We look into the data. Some people may call it exploratory data analysis. We try to open up the data, understand the structure of the data. If possible, we plot graphs to see whether there are things that look funny in the data. So that it has to do with data understanding. We are going to practically demonstrate these things. Then we go to a stage we call data preparation. Data preparation is where we handle noise in the data. Noise in this case could be missing values. There could be values that are too high. There is, assuming that you are looking at people's age, okay, on people's salary in a company's employees database. Now you're looking at people's salary. Everybody was earning the minimum wage, 30,000 naira, 30,000 naira. Automatically, you see a value that is 2 million naira amongst the salary of an average of 30,000 naira. You will question such value. Such values can be called outliers. Okay, so this is what data preparation handles. It deals with anomalies in the data. Then when we are done in the data preparation and clean up our data, we move to another stage we call modeling. We'll go more in depth into modeling. Modeling, the way I define modeling, it is the process of converting data into knowledge. That is what we, in terms of data science definition, that's how I define it. The process of converting data into knowledge. This knowledge can be underpinned by mathematics, by algorithms, by 3D models or whatever. So that is called modeling, the process of converting data into knowledge. Then when we have these models, we want to be sure that the knowledge we have driven represents the reality of the business. We want to make sure that it is not, it correlates with what domain expertise says. So we use domain expertise to evaluate the model we have realized. Then we talk about deployment. After doing all these things, you have to communicate to the executive. You have to write executive summary. You have to maybe demonstrate what you've done using a business dashboard, using whatever tool you want to use, but you want to be able to communicate whatever you have done. Data science is all about storytelling. If you are not capable of making it a story, telling them from the process, from the business angle, what represents, you know, things, tell them story they've not heard before from their data. That is what data science is all about. And to be able to tell this story, you need tools to do that, including maybe a business dashboard, an interactive plot, or something like that, to be able to do that. So in the course of our practical demonstrations, we will try to represent different stages of this workflow that we have here. So we've talked about modeling, and I say that modeling in data science, from the way I define it, means transforming data into knowledge. This knowledge can be a predictive knowledge. You are telling the company, based on what happened now, in the future, this will happen. Or you are telling the company that if someone behaves this way, that person is a fraudster. If he doesn't behave this way, that person is a genuine person. So this is the kind of knowledge you realize from data. And so we look at different types of models. Here we have regression model. Now, what regression model helps you to do is to make prediction. But if we look at the nature of what we are predicting, it is always a real value. For example, assuming that we want to, based on news on Twitter or other media platforms, we want to predict what exchange rate will be. So in that case, we are making prediction of real value, because exchange rate can be from any number from 0 to infinity. So in that case, it is not discrete. So it's a range of real value. Okay, so we talk about classification. That will make us understand regression model for those that have not heard it before. In terms of classification, assuming that we want to group people into their gender, male or female. So in that case, there are two categories. So it is discrete. That is actually the opposite of regression model, where you have to predict a real valued output. In the case of classification model, you are trying to tell 2 or 3 or 4 things apart. This one belongs to this one belongs to this one belongs to this. That's what you're trying to do. Then we have something that looks very closely to classification model, and with that is called clustering. Clustering does something similar to classification model. It tries to throw in some data into it, it separates them into groups. But the key difference between clustering and classification model is, in classification model, you have to tell the algorithm exactly what you expect from it. To give you some example, you should be able to, if you want the algorithm to distinguish people based on gender, you must have done it based on some parameters. And you're submitting these values to the algorithm to use your own example to learn how to do it. But when it comes to clustering, you are not having this example. The algorithm does not have this example because you don't even know it. So it's actually a very powerful tool. So a typical example of where this is used is in customer segmentation. A particular business, assuming a particular business has millions and millions of customers. So these millions of customers, they want to understand these customers and be able to design market programs to improve their revenues. Now, if they want to know each person individually, it's going to be difficult. What are they going to do? They will decide to put these people into groups. So they will now carry the behavior, maybe the transactional behaviors of these customers, their visitation into the company, their purchase style and or habits. They use these values, they throw them into a clustering algorithm. Their clustering algorithm now put them into different clusters, separate them up, tear them apart based on these attributes that you didn't define. Now, when they do that, the business is able to look at it using domain knowledge. They're able to say, okay, this particular group are people that do not, they come once in a year. This particular group are people that come every day, but they spend a very little amount of money. These are people that come every day and spend huge amount of money. Based on this, now they can design market programs that will benefit or will improve the loyalty of each of these sectors or segments. So that is an example of where customer segmentation is applied. So here we look at machine learning taxonomy, trying to understand different types of machine learning algorithms. So we are not going to go into trying to explain everything here, but in a very high class, machine learning algorithms are classified or grouped into three. We have supervised learning, unsupervised learning, and reinforcement learning. Supervised learning, if you look at this, we see we are having classification. I said something about classification. The classification needs an example from human, an example to be able to do its task. If this example does not exist, it will not be able to do it. So where you have not, something has not been done before manually, supervised learning fails. It needs an example. And the types of algorithms that are under supervised learning are classification and regression, as we have already explained in our previous slide. We have already said that clustering does not need any form of example, so it belongs to the unsupervised learning. Then we have reinforcement learning. Reinforcement learning is not a popular method among data scientists because it is applied in what we call situated agents. Situated agents are agents that are capable of perceiving their environment and acting upon that environment using actuator. Example is a robot. A robot has arms, has legs, okay, has sensors, maybe camera or something like that, that helps it perceive its environment and act upon it. Now, the way, so it is, reinforcement learning is rarely applied within data science, although it can be applied. So how reinforcement learning works is this. The same way we train our children at home, your child comes back and he became first position in school, you decide to buy him his best gift. Say, what do you want me to buy for you? It tells you want to buy him a toy. He wants you to buy him a toy. You buy a toy for him. You are making him, you know, encouraging him to do more. You come back, he broke your television. You are not going to buy him a toy. You have to do something to discourage him. You decide to punish him or decide, I'm not going to buy a Christmas clothes because you broke my television. So in that case, you are using a reward punishment system to correct his behavior. That is exactly what reinforcement learning is all about. Where we define reward function that tells a situated agent or any form of agent how to behave well. That is reinforcement learning. Most of my work are based on reinforcement learning and unsupervised learning. So we look at data science toolbox. These are minimum skills for data science. First, if you want to be a data science, you must know how to query a database. If a database is given to you, you should be able to write, depending on the type of database, whether it is NoSQL or SQL-based database. You should be able to get data out of that database. You should be able to update the database. You should be able to delete information from the database, or read information out of it, or create a new information into it. So that is the first skill you need. So most popular tool that people use to query database, SQL-based database, is SQS, structured query language, which is very important. We are going to demonstrate that too, but not in detail. So the essence of this presentation is not to make you an expert, is to be able to tell you the roadmap to becoming an effective data scientist if you want to be. So the second stage is data visualization. You should be able to see your data plotted in a graph. Okay, data visualization is very powerful. They say a picture worth more than 1,000 words. So data visualization can speak volume. Assuming that you finished, applying your data science skill to a particular data, and you want to report it, you don't come and show the company codes and mathematics that you've written. Some of them don't even understand those things. So what they want you to tell them, they want you to tell them in layman terms what you have found. And the easiest way to communicate these ideas or your findings is by using data visualization. You plot these things in a graph and you're able to tell them, last year, the company was doing at this level, but next year, look at what your KPI is doing. It has jumped up and other. That's what companies want to see, especially the executive. They are not interested in your mathematics. They are not interested in your code. They are interested in showing me something I will understand. Then we have the data preparation stage. You must know how to handle problems in data, such as missing values, such as outliers. You must learn how to do that. Then you need minimum skill in machine learning. Minimum skill in machine learning is an extremely mathematical topic, but there are a lot of libraries that have made it very, very, very simple to apply machine learning without even understanding them. Algorithms without even understanding them. Okay, so people apply it as black box. At least you should be able to apply it as black box with minimum understanding of what those parameters in that algorithm or that library are, so that you can tune them and make them better when they are not performing well. Again, you should be able to deploy your models. And this has to do with, you don't need to be a software developer. There are a lot of tools out there that you could use to quick build an app that you can use to demonstrate what you have done. That is what companies understand. They don't understand this way you are speaking in mathematical terms. They want to see something that they will understand. We are going to be playing with all these things here. Then communication. As I said before, data science is all about storytelling with data. You use data to tell a story, okay? Pushing from what business understanding, talking about what you found in the data, what is not there, to your findings, and trying to relate that finding to the business need of that particular organization. That is what data science is all about. So effective communication is an important skill for a data scientist to have. So these are the important tools for data science. We have Power BI, we have Excel, we have Tableau, we have R, we have MATLAB, we have Python. I know some people are surprised seeing Excel here. Yeah, Excel is a very effective data science tool. And I tell people that it doesn't matter the tool you are conversant with. Okay, data science is, the workflow is very important. Having the workflow and being personally creative is what you need as a data scientist. Although in this presentation, we'll be playing with Python. And what we'll be talking about, we'll be looking at these libraries in Python. Pandas. Pandas works like a cell within Python. So it helps you to manipulate your data. We have talked about SQL as well, structured query language, which helps you to get data from your database or send data into your database and things like that. So we also have Seaborn. We'll be using it to visualize our data. We have scikit-learn, which is a library for machine learning application, which we'll be playing with as well. We will also play with Pico. So Pico helps you to save your model. So we are going to use Pico to save our model so that we can deploy it. You will see how we are going to do that. We also have Streamlit, which gives us a server to run a web application, which we are going to do a very teeny tiny model, an app that we're going to deploy whatever model we are going to train in this presentation. So this is everything from the overview point of view. So this is not the end of the presentation. We are going to be going into trying to see how the applications of everything we've discussed now. So I want to start by introducing us to something we will be using. So there are different IDEs for applying Python, right? Or writing Python program. One of those IDEs or one of those platforms is what they call Anaconda Python distribution. So this is what we'll be using. One of the reasons why we are using it is because it is easy to use, basically. So if you download it from here, you're going to be, if you're using Windows, if you're using other operating system, you can download, and it's very easy to install, can download and install it. So I have downloaded and installed this, so I'll be using it. Now, one way you can use it, launch it, is by looking for what is called Anaconda Navigator. When you install it, Anaconda Navigator comes with it. So you don't need to install that separately. So it's part of the application. So when you click on this, the Anaconda Navigator will open. So let's wait for it to open. Okay. Oh, where are you? Okay, so we have it. So what do we need to do? We come to where we have Joy Python notebook and we click it. When we click that, we launch it. So that's what we've launched. This is what we've launched, and this is what we are looking for. But so there is another way to open it or to launch it. We can use what we call Anaconda prompt, which also comes with it. So when you click Anaconda prompt, you open a command line. If you are good at using command line, just on it type Joy Python notebook. Okay, so when you click on this as well, the same thing that runs a server, that's also open. So when that opens, we go to where we have our project. So I'm going to go to where I save our project. So our project is NSE Data Science Tutorial. So I'm going to click that open. I have an existing, because I don't want to be writing everything from scratch. That will delay this presentation. That will take us another 3 hours to do. So I decided to write everything and explain them as we run them. Then, so I'm going to open this. That is what we call a notebook. We call it a notebook. So we have NSC Data Science Lab. That's what we call a notebook. So let's start from here. The first thing we do is to import the libraries that we are going to use. Even if you don't understand Python, just pay attention to how we follow this, the framework, the workflow we presented. That will help you a great deal. So what do we do first? We first of all import the libraries we need. Here we need pandas. We talked about pandas, and I told you what pandas do. Pandas works almost like you're using Excel. So we are going to see that in real life how it works. So the actual application or library is pandas. So we imported pandas, but I decided to give it an alias. So even if I remove this, it's going to work, but that will make me, each time I want to write it within my code, I'll be writing the whole of it pandas. Okay, so I don't want to be doing that. I want to be using something very short so that it will be easier to manage. So here we also imported another library called NumPy. I'm not going to be directly using my NumPy here. Okay, NumPy actually helps you to manipulate matrix manipulation. We'll not be using it here directly. But the reason why I had to import it is when you perform some of the data analytic operations we are going to be doing, could be resulting to NumPy. So if we don't have it, at times we run into error. So that's why we want to make sure that we have that as an object here. Then here we'll be using visualization tool. We're going to be using Seaborn here. Although we have this one called Matplotlib, okay? This is why I'm putting this here. We're not going to be using it directly. This is the most basic. This is what you see more often. If you're looking at other people's code, there are other ones that are also very good. We have the Plotly, we have Dash, we have Boki, okay, that are also very good visualization tools. But we'll be using Seaborn to visualize our data. Then we have sklearn. I know we've heard about sklearn just in this presentation. sklearn helps us to use machine learning. You're going to see how easy it is to implement these things. So we are going to be applying a machine learning algorithm called decision tree regressor. That's what we'll be applying. So I've already imported it here. So this is not that important. The export graphics, that's if you want to plot the tree itself, we'll not be doing that, because what we are working on is a regression model. It is always difficult to plot the tree. So this is also important. I'm going to talk more about what we have here, where we have train, test, split. I'm going to talk about that later. So I will remember to talk about that at the later stage of this presentation. So also we are having HKLM for evaluating the model we are going to create. So we have this thing called R2 score. So R2 score helps us to compare the correlation between two outputs. Okay, let me say two vectors. Basically, I'm trying to avoid anything technical. Two vectors. So they help us to compare the correlation between two vectors. So here we have this library for connecting to database. We are going to be connecting to our database, okay, using what this library here used to connect to database. Now remember we talked about Pickle. Pickle is used for saving your model and loading it back to somewhere you want to use it later on. That is what Pickle is all about. So I don't want to, this can be removed, but why I'm leaving it here is it just a warning catcher. So it doesn't contribute to data science. There's nothing data science about it. So just assume that it is not here on the slide. In case I have some warning coming from my database connection, coming from the way I use some of the libraries. So I want to use this to prevent it or catch it. That's what this is all about. Okay, so let me run this so that we make sure we have all these libraries downloaded. How to run a particular cell. So one thing you should understand, let me make this smaller, smaller. So the GeoPython notebook is divided into cells. This is a cell, this is a cell. So you are coding into these cells, right? You're coding into these cells. Okay, so how to run a cell, because we'll be running them cell by cell. Okay, why I'm using it this way is so that we'll follow it systematically. To run a cell, you press down the shift key, okay? And you press your enter. So I've run this cell. If you look at it, you see that I've just run this cell. Okay. Now the next thing we are going to do is to load our data. Firstly, there are different ways a company can present data to you. Maybe they don't have any infrastructure, but they have got an Excel sheet. We have a flat file or an Excel sheet where they have stored their data. So you come, they say, okay, we want you to analyze our data. Then what they do to you, they say, okay, we are going to give you the data. They copy something in flash drive, an Excel sheet, and give to you, which you are going to put on your local computer. Okay, so like I'm having a file here. That's my data here. So I'm gonna put this here. So I'm having, so the data here is reactor data. So that's what I'm having. So I want to load it. So because they have given it to me in Excel format. So this is pandas. This speed represents pandas, right? So if you say read Excel, as simple as that, you will be loading that particular data. So if we run this now, okay, we've run this. That will be loading that data into a notebook. So if we want to see it, let's say we want to see it, please, if you've not used Python before, take note that whenever we see hash key, it represents comment. So we can remove that comment. Okay. So data.head helps you print the 5 first columns, the top 5 rows of your data, and that's what we want to do. So we are printing the 5 top rows of our data. Remember that this is data that we just loaded. So we are printing the 5 top rows. So from 0 to 4. Now, if you look at, so let's all look at this data very a little bit to understand what we want to do here. Okay, that is part of business understanding. The first column represents status, telling us whether, so let me explain it, let me make us understand. This data is coming from a real estate company. Don't worry, I'm not breaching anybody's privacy here. I got this data from Cargo. Okay, if you know cargo.com, I got it from Cargo. So it's a publicly accessible data that I'm using. So we have status tells us, so this is a real estate company that sells houses for people. You have a house you want to sell, you give it to them, they put it out there for sale. People buy them, right? That's what they do. So this status represents if that house is for sale or not. So for sale, right? This is the price of the house. This is the number of beds in that flat. This is the number of bedrooms. This is the size of the house, how big the environment is, the address, the city, the zip code, and all that. So those are the values we have in the data, okay, what the data represents. So it's coming from a real estate company. Yeah, so assuming that what they want us to do is they want us to be able to use these parameters to predict what the price of the house, of a house will be. And they don't want, what they want us to do is to do this and put it up in their website so that someone doesn't need to call them on phone to find out the price of a house. So if you have a house to sell, you just pop in your parameters, the variables into that particular web application, and it tells you how much they're going to sell your house. So you decide right from that point whether you want to, contract them or not. That is what they want us to do, to help them predict prices and tell their potential clients what the price of what the quantification for their house is before they go ahead having a contract with that particular person. That's what they want us to do. So we've talked about one way of handling it. So assuming that they gave us a Excel sheet, we can load it from our computer like this. But that is not always the case for a big company. Big companies will have the right infrastructure, so they will not be using Excel sheet. So what they are likely to do is when you come, they have a database, they don't have time to start getting data from Excel. What they're going to do for you, they tell you, we are going to give you a privilege to log into our database, right? You'll be able to log into our database. When you log into our database, you get the data you want and do what you want to do. We want you to solve our problems. So you come as a contractor or as a consultant, they will give you login credentials into the database. So assuming that these people have provided us a database, this is the database of the company, I'm going to bring it here. So we have this database here. This is Microsoft SQL Server. So I'm going to connect my database. So it's saying not connected. If you're looking, if you can see that, you can see not connected. So I'm going to make sure that we are connected. So here I've seen, you can see NSE Glasgow. I just created the database for this particular class. So I can go ahead to connect my database. So I connect it. I hope it doesn't give any problem. So let's see. Yeah. Excuse me with this. Okay, so let's go ahead. I think you can still access it without the connection, hopefully. So we've got this database here. Now, the same data we have in Excel is what we still have here. Okay, if you look at it, you see status, price, bill, and things like that. That's what we still have right here. Okay, so the same data we have. Now, what this company did now, they didn't want us to have Excel, they have the infrastructure, so they have a database, they give us the login detail. So what are we going to do with this? We are meant to query the database. That is where SQL comes in. Okay, that is where SQL comes in. But before we do that, you should remember this particular library that we mentioned that is used for database connection. So we need to create a connection object, and that is what we've done using this. If you look at this, we are specifying the kind of server we have, which is SQL Server. That's what we've got here, SQL Server. That's what we've got here, okay? So the next thing we do is we specify the server name. So if you want to see the server name, you can let me right click on this and go to properties. We will be able to see the server name. Our server name is this. So that is what I'm popping into that particular position. That is the server name. And what is the name of the database we are using? NSE Glasgow. That is the database we created here. So that is the database right there. So what next should we do? So this So this is in our computer, so we are using it as, we didn't put in password and stuff like that. So we're using it as a trusted connection. So we go ahead with that. So let me see if we can have this connected. So we run it. Okay, that ran perfectly well, so it's connected. Then we can go ahead. Let me just confirm that it is connected. We try to print out this connection object here. This is a connection object. We want to print it out. When we run this particular cell, we can see that it's telling us that there is connection now. There is connection. So that's great. Now, what is the next thing we do? We create what is called a cursor. A cursor is just like a handle into that database. We want to be able to have a handle into the database to be able to do things and be able to pull that out of that database. That's what we want to do. So we execute this particular line where we create cursor. That is the syntax for that. So when we run that, we've been able to create this cursor. So what do? We write SQL statement. Remember what SQL statement is? Structured query language. What are we trying to do? We are trying to select everything in this particular, this represents table. This represents table, real estate. So if you go into our database here, we can see, if you come to table, we will see we have this table, this thing table called real estate. So we want to get information from that table. So we are collecting everything in that table. That is what this SQL statement represents. So we are going to run it. When we run it, so we've run that SQL statement. That is just the statement, but we have not applied it to our connection. So pandas will help us to apply it to our connection. Remember, this is our connection object. This is what tells us that we are connected. This thing here tells us that we are connected. That Q here is that SQL statement we've written. So what are we going to do? We are going to use this particular syntax, read SQL. That converts SQL statements into a table of values. So when we run that, okay, we are having an error here. I'm going to explain why we are having that. Okay, that is not an error. That is a warning. I'm going to explain what. But this is data we've already collected. To make sure that we are getting that data, let us change this SQL statement a little bit. This asterisk here represents we are getting everything. But now we don't want to get everything. We want to get only the number of bits. So we type bits. So if we type the number of just bits and we run this, we are going to be getting the number of bits. So to show you that this thing here does not matter. It doesn't affect anything. Okay. If we can condition this also, assuming that we want to use what we call where clause to make sure we are only paying attention to situations where the number of bits are less than 4. That's what we want to get. So we say where bit is less than 4. That's what we want to see printed out. So when we run that, oh, what did I say? Okay, so let me be sure of what we said. So we've not run this particular one. So let me run it again and be sure I'm not confusing myself. So we run this particular cell again and see the output is going to give us only situations where the number of bits are less than 4. That shows that this error does not matter. But I'm going to explain this error for those that are more technical. So this is recommending something to us, recommending what is called SQL alchemy. SQL alchemy enables you to interact with your database as if they are Python objects. Okay, so if you want to use SQL alchemy, that needs us. That is what pandas is more comfortable with. A lot of Python IDEs are more comfortable with SQL alchemy. So that doesn't mean that other methods of interacting with database will not work. Okay, but it's going to be very advanced because you need to understand object-oriented Python programming to be able to do that. So we are not using SQL alchemy. We want to keep everything as vanilla as possible. Right. Let me remove this because we'll be needing all our data for. So I think we have convinced ourselves that this warning is not affecting what we are getting. So let's go ahead to get everything out of the database. So we are getting everything out of the database. Now, we've been able to use SQL statement to get our data. Now we go to the next stage, which is data understanding, which is part of our workflow. What data understanding helps you to do is to understand what is in your data. We want to see what is in the data. First of all, let us see the columns. How many columns are in the data? What are they? We look at it. We see these are the things we have in data: status, price, paid, birth, to understand what these things are so that we can know what to do with them. So that is why we are exploring this data. We want to understand our data. That is what we have just done. Okay, so then the syntax that is doing this, let me edit this small so that we see clearly what we are actually doing. If I run this alone, we are going to see it's going to print out those things like this. So, but I made it clearer by converting it to pandas data frame. Okay, that's why it looks different. Okay, so, but this is the syntax that print out the headings for each of the columns. That is the syntax that does that. So looking at this is not enough, doesn't describe this data very well. We want to see more. We want to see the data types of these data, columns. So when we run df.data-types, that tells us where we have numbers. Wherever you see floats, that represent number. Okay, if you see objects, that could represent text. Okay, can represent empty values or something like that. So we can see where because numerical values are easy to process. So we are paying attention whether we're going to have an easy day with this job. That is why we are paying attention to see whether things that are interesting to us, if they are in numerical format. So we are happy we can have that our price is in numerical format, paid, VAT, and all that. If they are not in numerical format, we'll be thinking about how to convert text into numbers. That will be something for another day. We'll not be doing that. We'll be playing with numerical values. Now, looking at this, we say, okay, based on what we are asked to do, let us just look at status. Let us extract some of the variables. We may not be using everything. We say, okay, we don't need full address to do this. We don't need street. We don't need city. Zip code does represent those. So we go ahead to extract the things we want, just the things we want. We don't want everything. So we get the things we want and we store it. We use it to create a new data. That's what we call new data here. So we use it to create new data. So when we run this, we are going to have new data. So this new data now, these are what it has. It doesn't have full address. It doesn't have a lot of things, streets. It doesn't have, it has zip code, house size, and all that. Okay, so that's what we have in our new data. So we may want to describe our new data. So when we write new data.describe, that does descriptive statistics on the data. So when we run that, okay, when we run that, we are going to see this. It counts the number of number of values in the data. It counts, that's what it does here, basically. So it calculates the mean, standard deviation, minimum value, percentile, and all that. So it calculates that, gives us the maximum values and stuff like that. So this is actually a description of our data. Now, when we look at this, what are we going to learn from this description? We are going to learn, like if you look at this place, you see that price here is about 60 million. But look at other ones are less than that. We are covered about hundreds of thousands. But here is 60, am I correct? 60 million, that's what it is. That means, which means there is an outlier, there are outliers in this particular column. So if you look at this, you see these values are, we have 1 to 4, and automatically we now start seeing something, 40. That is an outlier. So we are already seeing outliers here, okay? And we're going to see how we can handle some of them, not all of them. So most of them have, most of the columns have outliers. Now, what do we do next? We decide to plot our graphs to see the relationship between these variables. So we are trying to see the relationship between house size and price. So let us run that. If we run it, then what are we going to see? Okay, we are seeing something. Now, when we look at this, you see that this value here is already affecting us. The price value here is already affecting us because it is too big to be here, too big. So it is already affecting us. Now, when we look at this, you see there's a value here which is also way away from other ones. What are we going to do? We go back to our query to make sure we don't have this problem. We are going to just handle the one of house size. We may not be able to handle all of them. Now, if you look at this coloring represents different states, you know. So when you have blue, it's talking about Puerto Rico, okay? You have Massachusetts here. You have South Carolina as green. It's not quite obvious here. So, and how that happened was, I put who state here. So that actually tells Seaborn that I want you to show me how the distribution of each state is represented in this data. So I want to deal with that outlier in the case of a house price. So I'm going to do something. I will go back to my SQL statement here and say restrict it a bit. This is not the best way to handle it, but let us do it in a vanilla way. So we're going to say house size. Okay, I'm just going to restrict house size. I've done this before, so we're going to have about 2,000. House size is not going to be more than 2,000. So let's see how that is going to change the plots we have. I'm running everything again until I come to that plot. So let's see what it's going to do to the plot. You see that the plot has changed. Just removing an outlier changed everything. You see how the plot changed. So, which means an outlier can change the way your data is understood. Okay, so we have made a difference now by just removing that particular outlier, right? Okay, so if we want to improve it more, the more we remove this outlier, assuming that we remove every outlier in this particular data, we are going to have a fantastic performance, but we're not going to do that. That's going to take us much time. Okay, so we're not going to do that. Yeah, but that improves a lot of things. So let us also look at how big varies with price. So when we run this, we say, let's see how bed varies with price. Okay, so we see how bed size varies with price. Okay, so we are seeing things here. We can see that Massachusetts is actually at the bottom. We have Puerto Rico is quite high. We can actually see this from this data clearly, that there is some pattern, although by looking at it virtually, we may not make sense from this data. So we can look at how the bath size, but number of bathrooms vary with the price of a house. We can do that. So we are looking at these things. Okay, it's also got some pattern. We see that of New York, we have more values around the, most of the houses have one bathroom in New York. We can quickly see that. So we can also, we can see how this distribution actually is only in Puerto Rico that they have from 6 bathrooms in a flat and above. So that is something, informative. And this is, what we are just doing is exploratory data analysis. We are doing it to understand our data. So we are not going to do more on this, but this is what you do. You play around with the variables, change things, try to understand how your data behave, what your data look like. That will tell you how to prepare your data better. So we move forward from here. Okay, so let's see something. Let me print out this data again to see exactly how the data look. I want to create a new cell. I click this, I move it up so that it will be up. So let's all look at how our new data look like after we have removed our outlier. So when we do that, we see, okay, so it's looking pretty nice, but there's something I normally do. I normally check if there are null values. Null values means empty cells in your data, assuming that you have values here, this place is empty, nothing is here. That is null. That is how Python or pandas will interpret it. So we are going to check whether we have any null values, because that also contributes to problem, right? So the problem when we want to model this data. So we run it and we see, okay, you see bed, we have up to 207 null values. That is not good. So Ecolot, see what we are having. So there are many ways we can handle this. We may decide to put in values there. We may decide to delete those ones. We are going to take the easy way out, which means deleting it. We can do better than that, but for the sake of this presentation, we are going to dwell on the vanilla approach to handling these things. So no need to do this. What am I going to do? I want to remove them. I think, okay, I handled that somewhere. That is here. Yes, I handled that here. So let me see what happened. Okay. Okay, so let me see whether that handles it. So I'm going to remove that. Now, most of the values that are null, some of them are represented as none, not a number, because they are empty. Pandas, we say they are not a number. So let us see how pandas will handle that. Okay, so let's run this and see. So if we run this, it is going to drop those values, right? Anywhere, any row that has any empty value will be dropped. That is what this any is. Okay, that's what it means. So when we do this, we run it. So let us run it and check whether we still have those null values. We run it again and check whether we have those null values. See that we have handled it. no null values anymore. Unlike in the previous case where we had a lot of null values, we've deleted them. That makes our data better, and this is under data preparation. What are we doing under data preparation? We are trying to make our data, easy to be modeled by removing noise, handling missing values, handling outliers. This is what we are trying to do in data preparation. So another thing we want to do is, remember that we do not want to use, we still have city, state here, we still have status. This is our non-numerical values. We can handle them if we want to. We can encode them using numerical values. But we don't want to do that. We just take the easy way out. Let us just drop those ones that have, those ones that are text values. We want to drop them. So if you write this code, new data.drop, that drops those columns. So we want to drop them. We now run this, and so we are dropping them. So if we come back and run our new data, we can see that we have dropped those ones. Status is no longer there, city is no longer there, state is no longer there. So this is what we have to work with now. So we have this to work with. So what do we do next? There is what is called scaling. Remember that we handled outliers on the house size column by changing our SQL statement. That is not enough. One way of handling outliers is by what we call scaling or standardization. Okay, there are two methods to standardization and scaling. The first method is what we call z-score normalization. So let me just show, I think I have something here that I can use to explain it. So this is z-score normalization here. So what z-score normalization does is it calculates the mean. For every value in that particular column, it will subtract the mean from it and divide it by the standard deviation of that particular column. So that is z-score normalization. So there is another one. So there's another one called min-max normalization. This is min-max normalization. Oh, okay. Now this is supposed to be mean. Okay, whatever is fine. So you subtract the minimum value of that column from every value in that particular column, and you divide by the range. That is min-max normalization. Okay. So, but what we are applying here is the z-score normalization. What do we want to do? We want to reduce the range of the value just between 0 and 1. Okay, that's what we want to reduce it. We want to scale it, bring it down a little bit so that our algorithm will be able to handle it better. So we go ahead to do that. Now we come into the modeling stage. Now what we are trying to do here, first of all, for us to be able to handle what we call generalization problem, we are going to split our data into two. We split it into training set and test set. Training set is what we use to train the machine learning algorithm. While test set is what we are going to use to evaluate to make sure that it is giving us a good result. So that is what this train test split does. So we are splitting it into 30%, 70%. That is what this value here represents, 0.3 represents, split this into 30%. So what we are going to do, when we split our data set, we are going to train with a portion of it and then evaluate to make sure that if the algorithm sees something it has not seen before, okay, it will be able to handle it. Because when we host our application, the customers will be bringing in data that we've not seen before. So we want to see how the algorithm will perform when it sees values that it has not seen before, that it was not trained with. That is why we are, and this is very, very important. People do more than this. They split it into three, having what we call train set, validation set, and test set. But we are not going to dwell into that. So let's go ahead to use this particular split. So we run this. Now, having split this, we are going to train our model. How do we start? Remember, we mentioned that using our SKLM, we imported this thing called decision tree regressor. So that is the model. Just this line of code creates a machine learning model for you. And we are going to do that. If we run that, so that is going to create a machine learning model for you. Now, this line of code actually trains it. That is how simple it is. So this actually trains your machine learning model, your decision tree regressor, as simple as that. So when we run this, we are having our X train and we're having our Y train, okay? So we are training this algorithm to be able to predict what is Y train, please. I have to make this clear. Look at our Y is price. Price is our Y, look at our Y. So this is price. That is what our Y is. What is our X? Our X are date, birth, zip code. That is what we want to use to predict the price, right? So our Y, sorry, I didn't explain this earlier. Our Y represents what we want to get, the output. What is the price of the house? Why our X represents what we want to use to predict this price of the house, okay? So when we use, now we take this example, the X trend, what we want to use the variable and the output we are expected to have for each of these variables, we use it now to train our machine learning model. So when we run this, we have, this line of code has been able to train this machine learning model, okay? As simple as that. We are going to see that later. Now, let us now make a prediction. We want to predict, use this to predict. This line of code, just this, helps you to predict. So if we run this, this will be a predicted value. If we run it, we have been able to predict. So let us compare. Remember what ARU2 score does? ARU2 score helps us to evaluate our model, tell us how close our prediction is to the real value. So when we run this, we are going to be having, okay, we are having about a 3%. Okay, that's what we're having. That's not a good one. The best performance, 3% is not a great performance. But, so this is not a 3%. This is ARU2 score. How ARU2 score works, basically, is when the value is close to 1, that shows high correlation. So it's more or less like correlation coefficient. When the value is close to 0, that shows minimum correlation. When it is negative, that shows uncorrelation, right? So in this case, there is some correlation, about 0.83 correlation, okay? So that is not that great, but we can further ahead with that. We can do better if we go and, if you want to read more about sklearn, there is a documentation, sklearn documentation, that you can go and learn about the parameters, how to change things in the parameters that will help you improve your algorithm. We will not be spending much time on that art here. So let us go ahead and check how our algorithm is performing on the test. The test set is what our algorithm has not seen before. It has not seen it. We trained it on the training set, but we have not tested it. So let us see how it will behave if it is deployed in production. So we do that about 0.7. That's not also great. We could make that better, but we can go out, we can make do with that. Okay, we can go ahead to do rescaling. Now, I may decide to plot, okay? I'm trying to plot to see how this is our prediction. This is the original. This is how our prediction matches the original, which is not too bad, but it's not a very great one. So that's what we are having, basically. Now, we are going to talk about deployment. Let us see how we deploy our algorithm. The first thing we have to do is to save the model we developed. The model we developed is called model. We want to save it in this file name, finalized_model. Model. That's what we want to save it as. So let us just save it. So we have saved our model, right? So that is going to be the starting point of our deployment. So what we are going to do, we are going to create a little app that's not going to take us much time. Okay, we create a little app and see how we can use this model on that app. Okay, so I have opened a Python IDE here. Python, let me just open it. So here we are going to be moving away a little bit from, sorry, this. It's not frustrating. Okay, so I'm going to do this now. Sorry, this is finding it a bit difficult to open this. So let me use this environment for it. So I will be okay. So I have to save. I'll be saving whatever I'm doing. So I will have to call it this. So let's see how it works. So this is a blank Python environment. So let's see. Remember, we mentioned something called Streamlit. We are going to be using Streamlit here. I don't know where this is coming from. So we are going to be importing Streamlit. So this is Streamlit. So Streamlit helps you to do a demo app. Okay, it's gonna be very easy. I'm gonna make it as simple as possible. So remember that we saved our model in Python environment. If we minimize this here, and let me say I open this. So I open this here. This is the model we developed, finalized model. We are going to be loading it into Streamlit and be using it. And for us to be able to load it into Streamlit and use it, we are going to do something with it. So we need this thing called pickle. So we talked about pickle before. So we need pickle. We need this thing called pickle to do that. Pickle. So having created that, so sorry, I'm having a little bit of issues here. Okay, so the first thing I do, let us just check the easiest thing we can do. So I want to call this Streamlit because I don't want to be writing everything all the time. I don't want to be writing Streamlit. I'm going to say ST. So I'm going to give it an alias. So let us test this and see whether we can go ahead to do something with it. So let me say ST. So I'm going to call this real estate. So to see whether we can have our server interact with Streamlit, with our application. So let us see. So how do we run this? I will come to where I have my file. I'll come there and I open my command line, just type CMD in that particular place where I have on my directory, I'm typing it on top of there. If I press enter, I'm going to have my command line come up. So remember that we saved whatever we are writing as app.py. So if I type Streamlit on this environment, I'm going to make it bigger. Okay, it's not coming up bigger. Okay, so if I type Streamlit, run that app.py, if I do that and press enter, a server is starting. So the server starts, we automatically going to see what we've done, okay, which I haven't seen. Okay, so let me be sure of what's going on. It's not happening. So I can refresh it. Let me be sure of what is going on. Sorry, that's problem with live demonstration of this. But I hope we can get that working as soon as possible. We have. Okay, so I'm going to open that with Python environment. Let me just do something different. Use Python environment to open that to be sure we are looking at it from a better angle. So I'm going to open that with Python environment so that if I'm making changes, I'll be sure of what I'm doing. Okay, so I'm looking at something different here. So let me say, do this here. Okay, so I'm going to clean my server and run it again. So let me run it again and see what's going to happen on that particular. So that prints real estate. That means we can actually interact with our server from the web browser. So that shows real estate. So that means we can get something going on here. So what do we do next? What we want to do next is to load. We want to load, or we want to create the different interface. So let's say we want to get an input from the user because we want to make prediction using the bed size. So we are saying bed. We say st text input. So we are going to tell the user, enter your bed size. So that what we want to tell the user to give us the bed size. So when we do that, let's rerun this. So we have enter your bed size, as simple as that. So a user can type in his bed size here. Okay. So let's go ahead and see what we can do again. So we can go ahead and say bath. We want the user to give us st.text_input. We want to get enter the number of bedrooms. Enter the number of bedrooms. So that's what we have. That automatically is going to update our website. Okay, so we see that enter the number of bedrooms. So that's what we have right there. So what we do next, we now want to be able to put a button. We say button, let me call it BTN. I'm going to say st.btn, as simple as that. So we can get our demo up. So we're going to say enter or click submit. We want the user to be able to submit. So we are doing that here. So if we go ahead and look at what we have right here, we see that the button has enter. So we have an app here. So what we need to do is to bring in our machine learning model into this app. We can connect this to database. We can do other form of design with it. So what we want to do, we want a situation whereby if somebody clicks this app, clicks the button BTN, we are going to say something, but let us do something funny. Let's just say st.success. So we are going to say clicked the button. So let's be sure that is communicating with our app as well. So by the time we do this, we are going to see. So if someone clicks this, we're going to say click the button. That means our app is becoming a little bit more interactive, but that is not everything we want to do. We want to be able to deploy our machine learning model. And let me go here. So this is how we are going to load our machine learning model. So I'm going to just load it using Pico as well. That's why we have Pico there. So we are going to say pico.load. I'm just going to copy this and go to where we have our application and put it right there. So what do I want to do with that? I want to be able to use this machine learning model that we trained to be able to give out an output. And how do we do that? We can simply say loaded. Our loaded model dot predict. So we want to make a prediction with it. Okay, dot predict. I think I have this thing somewhere there. So let me be sure. I think I've overwritten that. That's not good. That's not a good one. Okay, so we can go ahead with that. So let me say, so I have predict. I want everything this person has put in here, we want to be able to use it to predict our model. Okay, so we are going to say output. This is the output. So we have our output and we are making prediction. So when we make this prediction, what are we going to be using to make the prediction? We are using the values this person had put in, which include bed, which include bath, which include okay, we've not included something called zip code. So let's use just these two values to be sure we are doing the right thing. But when somebody types in something from that environment, these values will be text. So when we run this, we are going to have an error. So let us see, we're already having an error here. Let's be sure we are doing okay. So we are already having an error. File name is not defined. Okay, so let's see why they say that. File name is not defined. Okay, we have to define file name. What is the file name? Sorry, we have to go back here. We have this is file name. And I'm going to explain what that means. So if we go back to here, okay, we are putting in file name right here. So what is file name? If we open our project folder, we see this here. We see this. We see that. So this is actually file name. And this is the model we trained that we saved. The model we saved in that particular directory. So that is the model. That is the file name. So that we change, that we improve, we correct that particular error on Streamlit. Let's see, so that corrects that error, we are no longer having it. So what do we want to use that particular model to do? We want to use it to be able to predict. So if somebody, assuming that somebody, we are expecting an error here, somebody types that his base size is 1, and the number of bedrooms are 5. So if we apply this, we are going to have error here. So why are we having error? We are having error because what we are applying, firstly, we are applying floats and text instead of floats. So whatever you enter here, Python sees it as a number. So as a text. So how do we handle it? We are going to convert this to float value. Okay, so by just typing float. So when we type float, we are going to be converting this, okay, to numbers. That will not still solve our problem. We still have a problem. I'm going to tell us what we are having. Okay, so when we put in this thing here, we are going to, okay, let's submit again. Let's say we're going to be having another error talking about shape. Okay, so this value is not in the right shape. What we are putting here is not the right data type. I remember we imported numpy before. We're going to import it again. Numpy with this alias as MP. So we're going to import that again. What are we going to do with it? We are going to use it to put whatever we are typing in here in the right format by saying numpy.array. So this converts our numpy, that list, into a numpy array. So we are putting it here, and not Streamlit complain about shape. So we are going to reshape our data, right? This is how we want us to reshape it. So I'm going to just reshape the data to make it compliant with the model we are applying, the format is expecting it to be. So we're going to say reshape. So we are reshaping it to that. Okay, so that's what we are reshaping it to. So when we run this, we are not going to have, I don't expect us to have any error, but we are having, but decision tree is expecting 3 features. Oh God. Okay, so we needed that 3rd feature because we trained it with 3 features. So let us include that. And that has to do with zip code. Sorry, this is what we see when you are writing code, you must expect some of these things to happen. So let us just have the next one, which we call zip code. Okay, we're having zip code. We are almost there. So we have st.text, okay, underscore input. So we are going to say enter zip code. So I'm going to correct this there. We have this problem right here. So zip code is going to be one of the variables. That's what Streamlit was complaining about. So we're going to still say float, and we have our zip code entered right there. That's what it expected us to do. Okay, so we close it in. Then let us check whether we have improved what we have. Okay, we have 3 values. Let us include zip code and check what happens with zip code. Okay, we put in zip code right here. So let's run it. So we run it, and what are we going to have again? Has 1 feature, but decision tree is expecting 3 features as input. Okay, so let's see. Let me see what's going on right here. Sorry, I would have written this somewhere maybe and demonstrate it. Let me see what is happening right here. Okay, we have that. I can't quickly see that. So let me check here. I think I have that right here. So we're going to have this. So we have this stuff predicts. We have that. So I'm going to import this. So I'm going to import that. Let me see, I'm importing this. So I'm going to import the library that does that. Basically, so let me import this to be sure we are having the right things right there. Okay, this is taking a little bit time, but I've just done that somewhere and give it. So I'll leave this from here. So we have like this, we have that, we have that, we have that, we have that, we have that. Let me see, what is this closing down? I expect this to work. Let me see. So we run this. So that error continues. Yeah. I think I've got to stop here for now. Maybe.
Yeah, engineer, well done. We are just looking, just to watch out for the time. I know people are really, enjoying which is good, but just for us to, if you don't mind, thank you.
Okay, I'm gonna stop right here.
Thank you.
Sorry about this. I would have demonstrated that somewhere, be able to do it. Okay, that worked. Sorry, I'm gonna finish this, please. So let me just be sure we are doing the right thing here. So I'm gonna be printing that value. It doesn't need to be the best ever. So I think my reshaping was wrong. I'm gonna be printing this. I say price. So this is the price. So that's what we are going to be printing out. And I'm gonna be taking it out from this because it's gonna be an array. So I'm gonna put this. So let's see what's gonna happen basically. So we don't want this error anymore. So it's like that's a comma, that's simple to handle. So I'm gonna just put a comma right here that handles it. Okay, so if we go to that and run this, oh my God, the output. So that wasn't spelled very correctly. And we're going to do this here. So to be sure that we all agree that this works very well. So we press that. Okay, it's okay. Like I'm having success. I would have supposed to have a right, please. That's what is causing that problem right there. That's supposed to be right. Okay, sorry I took you through what I passed through when I'm writing because a lot of problems. So that prints out this. Remember that this is normalized. We can convert it to rescale it back to the real values. I think this is good for now. We can say, lucky enough that I was able to get this done. So that calls for a little bit of balance. Okay, yeah, that's no. Okay, balance. Okay, yeah. Okay. Balance. Okay, that's all right. That's all right. So we stop right there. That's everything we're going to do. So that's it. We can rescale it using the formula we have here in terms of this. In terms of the scaling, the value we have here, we can multiply if whatever value we have. If we extract the standard deviation from that column, we multiply it with Z and we add our mean there. That will solve, that will make us have the right scale for that. I don't think we have time for that, so we can do that. But this is a little bit of an app. Sorry, this was, I would have done this somewhere, but I didn't find time to do it somewhere before I started doing it. That is a lesson for me for next time. I will make sure that I have these things written out the same way I have on my note that will reduce the amount of errors. Okay.
Yeah, engineer Chinedu, just to, you can, before you summarize, just to people that stay online, they don't need to drop now. I think there will be another section coming up, which I'm sure you'll be happy to deliver as well. So yeah, I'll leave it on there for you to continue. Thank you.
Okay, that's great. So what are we? I think we are going to question time, isn't it?
Oh, okay. Thank you again. Thanks so much, Engineer Chinedu, for this. It's practically you have made us programmers here within how many minutes now, because we've seen everything. We've seen you retrieve data. We've seen you visualize it. You've applied, very, very advanced algorithms. You were already building a website, a very interactive one. So we've gone through everything.
Yeah, machine learning. Pass through the problem of coding.
Yes, you have not hidden anyone away. So this is the life of a programmer that sits down throughout the night trying to bug and debug and manage all of these things. Thank you so much for exposing us to this again. The last time it was similar in MATLAB. You took us through all of it, and this is a very, very great one. just to inform everyone that the recording will be uploaded to our YouTube channel, and the PowerPoint slides as well will be uploaded there, so you can download easily. You can rewatch anytime you want, and that's how it goes. Thank you again, wonderful Engineer Chinedu, for this session. I would want to, on my feet now, just thinking to just survey briefly, if we have a training session that starts from the very beginning, how to download Python, how to do addition, multiplication, division in Python, and play with from basic codes until you grow to the machine learning and all that in sessions, maybe per week, or 3 lessons a week or something like that for 2-3 months. Would people be willing to register and participate with that? So we have Engineer Chinedu and a couple of other people from our branch who are able to manage that, on a weekly basis. If you're willing to participate in something like that, just put a thumbs up or a yes or something in the chat, so we have an idea, and then we can manage how to arrange. Okay, right. Awesome. I see lots of thumbs up. So we would be able to talk about that after now, because this requires really going from the step by step and growing with it. There are so many materials online, but it's much better if you have somebody like Engineer Chinedu who you can relate with directly. You can have it synchronously, be online with him live, ask questions even after it has been uploaded. So it's more like an online teaching school for Python. We will look at how to organize that as NSC Glasgow and get resource persons on board with it as soon as possible. So continue to, all right, great. Seeing lots of interest there. Yeah, Engineer Chinedu, you've done a great job. And yes, we'll keep this going and see how we will consolidate on it and come out with a program. I think this is very necessary. The last time we talked about Python, we had over 7,000 views on YouTube. And I'm sure this one as well is going to, shoot up real shortly. So it's better to just have a good structure and get some kind of short certificate program with the whole Python data science gamut all together in 3 months or something, maybe 2 days of 2-hour session live. And then you can also send emails and questions and chats to have the resource persons at your disposal. It will cost money anyway, because these guys, their time, we have to pay for their time. Yeah, exactly. Thank you so much. So yeah, we have a very short time now. I'll just open the chat. I think Engineer Sharp is not able to join us today.
I don't think so. Maybe I will take.
So I'll give it to Engineer Favor to Engineer Favor manage the Q&A. We have a very short time, so please.
Okay. Yes. Thank you, Dr. Emma. So we are, and thank you, Engineer Chinedu. That was a great presentation. For the Q&A sessions, we're going to use a similar modes we've used previously. So you can either type in your questions in the chat box, or alternatively, you can raise your hands using the raise hand function on Zoom. So I've already started seeing some questions and hands raised. So I'm going to take them in the order I saw them. I think the first one was a typed in question that came from Mohammed Adam. And it says, as a beginner, how do you know and familiarize yourself with these codes to use?
Yeah, code is, when people talk about programming, they think you're going to have everything in your head. I don't see. I was making a lot of blunders here because I didn't have to, I didn't have all the resources I needed, right? So in programming, there are a few things you need to know. You have to understand the syntax of the programming language you need, right? Okay. If you're interested in Python, you have to understand basic syntax, okay? Understand print statement, understand for loop, what we call programming construct, for loop, how to do for loop, how to do while loop, understand what we call data structure and algorithm. If we have another time, we'll work on these basic programming skills. So if you understand data structure and algorithm of the programming language, you have started. Most of the things are things you could ask on the internet. So no one has every code, everything, every syntax in their head. No one does, right? I don't. So why I had to run into problems is because I couldn't check on the internet or Google what to do because it's a live session. But if I work privately, I use my Google, I use everything, Stack Overflow. There are a lot of platforms you can pose your questions and get solutions to it. So you don't have to have all these things in your head. You need the basics. The basics, everything you need, and practice it. That is enough for you to start with. Yeah.
Okay, thank you. Thank you very much for that great answer. I think that's another justification for us having those foundation courses maybe, and we'll speak about that in more detail offline. The next is OA Adiaga. Please, sir, madam, can you please ask your question? Yeah.
Thank you very much, Mr. Moderator. Let me first appreciate the presenter, Engineer Chinedu, who has actually done justice to Python. I'm also a programmer like him, and maybe shortly, what happened now is not peculiar to him. During one of the PhD defense in University of Aberdeen, when the man has already fixed everything, it was to run the program for his PhD. It was funny, it ran for almost 3 days. The result could not even come out. Something he has run and has presented and formatted his thesis. So what Engineer Chinedu has done, it shows that he's a good programmer, because a programmer doesn't get it once, but as soon as you get it, you take on. I appreciate you for that. You are a very sound programmer. Be that as it may. Now, the syntaxes for Python and other programs too are almost similar. But then, how do you advise, or what do you advise a beginner? Because I have many of my students online right now. They are actually in this. What do you expect a beginner to start with? Or somebody who is actually working on his thesis, on his final year project, what is your advice to start with? Thank you very much.
Yeah, so programming, it doesn't matter the programming language you start with, whether it is Python or C++ or Java and all that. What you need is to have that programmatic mind, right? So there's that mindset of a programmer that when you see, so if you're already a programmer, you want to go into, like, I use Python, I write MATLAB also, I write C++ sometimes. If I want to do Java, I've not been doing Java, but if I want to do it because I understand programming constructs, what I'll ask is, in Java, how do they do this? I know how to do it in Python already. So I'm asking, how do Java do this particular thing, right? By the time I pick those fundamental things, I'm quick to catch it. So the basic programming is the most important thing, no matter the language you learn it in, right? Whether it is in Python or it is in C++ or whatever programming language you used, right? So that's what they need to know first. But knowing the syntax is not enough. If you want to really use programming to solve real problems, the syntax is not enough. I have a lot of people, they know 50 programming languages, but they have not solved any real world problem. That is not good. You are just a syntax, you are a dictionary for syntax. Solving real world problem is different from knowing syntax. You should know how to, what you call hack. That's why we do hackathons. This is where people come and they handle real world projects. Do you understand? That's what they do. They also do web application, develop web scrapers and things like that to help them master a particular programming language or how to solve a real world problem. So what I advise beginners is, once you learn how to code, try to do a project. Don't just rely on the code. On your own, decide, okay, I want to do a hotel application, no matter how small it is. Do end-to-end application, okay, or that hotel application. Or if you're going to data science, say, okay, I want to analyze, there are a lot of data out there. You're seeking for who to analyze them. On cargo.com, you have data. On UCI repository, you have data. The data are public, are there for public domain. Okay, so what you do, download those data and say, I want to do data science on this particular data, starting from business understanding, following a workflow, okay, to analyzing this data and to publishing it, building a dashboard, maybe even putting charts and graphs on that dashboard, right? So by the time you do that, you see that you are committing this to memory. It's not all about syntax. It's all about knowing how to use this syntax to solve a problem. Yeah.
Thank you. The next question is from Moses. It's from Moses Ibideron. Hopefully, sorry, I pronounced the name correctly. Please, can you ask your question?
Yeah, I don't think he can get it. He doesn't have the voice, so maybe.
Okay. All right. While you're trying to sort out your connection, Moses, and we'll move to the next person, Engineer Joe Frank. Please, can you unmute yourself and ask your question?
Thank you very much. I really appreciate this session. So my question goes straight to the point. You mentioned the
Engineer Joe, I think that your audio is not clear. I don't know if we can't hear you again.
We can move to.
Okay, yeah, I think maybe we'll move to the next person and then we'll come back to you, Engineer Joe, once you've been able to sort that out. The next I have is Uniemi Akpabio. If you can please unmute yourself and ask your question. Yeah.
Can you hear me?
Yes, we can hear you.
Yeah, perfect. Thank you, Engineer Chinedu. I really appreciate your time out to speak with us about data science. Quick one. So I'm pretty much familiar with the data science term, and I've been doing some coding privately. But personally, I prefer to use Google Colab as opposed to using Anaconda. Yeah. What are your thoughts about it?
Yeah, Google Colab is a great tool. The reason is because it provides you with HPC as well. Because when we talked about big data, we talk about the 5 V's, and one of the things we mentioned is volume. If you want to run very big data on GeoPython notebook, you may find it difficult because it may run forever, right? But the Google Colab provides you with the infrastructure, GPU, to be able to use to run these things in a very fast pace. But one problem with this is a free product from Google. So you have to consider the privacy of your data. Whatever you throw into Google, Google own it. So you have to know that. So if a company gives you data to analyze, you have to consider the confidentiality of that data. So you have to be mindful of where you're running it. If it is not sitting on your local server or the infrastructure the company has provided, some of them maybe want you to use Amazon Web Services or things like that, or infrastructures in the cloud. If it is not on a safe place, you have to be very careful because you could be throwing away the company's data to people that don't supposed to own it. Okay. Is that okay?
Yeah. Oh, sorry. Okay, and the next question is from Oluremi Hamid. If you can please unmute yourself. Yeah.
Okay, thank you so much for this presentation, Engineer Chini. It was very insightful and very helpful for beginners like me. So my question is, recently I asked a tech sister of mine who I know is a very good programmer, how I could, start learning Python. And she told me Python is not a language that I can learn by myself. So I just want to know, is that really true? Is it something I can learn online, or do I need somebody to put me through? I was able to get some information online, and of course, while you were taking the class, I mean, it was very familiar to me because I had gone through that. But I just want to know, is it possible to learn Python by yourself, or do I need somebody to tutor me? Thank you.
And I want to tell you that I learned Python by myself. So I think that answers your question. So no one taught me Python, I learned it by myself. So if I learned it by myself, you can learn it by yourself. Okay, so it's not something someone must teach you. There are many information out there that you can use to learn. Okay, so don't get discouraged by anything. Keep learning it. What you need, in as much as you're learning it and you are practicing, you are taking challenges, if you see hackathons, participate in them, you get better and better. Yeah.
Okay, and we'll take, maybe because of time, we'll take the last 2 questions. The next one is from, it's on the chat from Abu Kori, but I think you're also raising your hand. So I'll just ask you to please unmute yourself and ask the question.
Thank you very much, Engineer Chinedu, and thank you very much, NSC Glasgow, for the presentation. For us that are not in the mainstream programming and we have, let's say, engineering problems and we have data at hand. So are there any ready-made packages like that we can just use like step by step, 1, 2, 3 that can easily like sort out the data? We have the data, let's say, for instance, on let's say rainfall forecast, and we want to build a system to predict rainfall. We have the data on every day, the timing and everything. So are there any packages that we can just use? We are not, we are not conversant with the mainstream. We are not into the programming. We just wanted this data to be sorted, structured, and we get our interpretation to just inform decisions. So what do you advise in our case? Thank you.
Okay, so yeah, there are packages you can use to do things. Like you have Power BI. Yeah, Power BI is there, but although at the back end it needs Python, I think the easiest one you can use is Tableau. They call it Tableau. Tableau also has already off-the-shelf models that you can apply to such data without coding. There is also Weka, W-E-K-A. I've used Weka several times. Weka is easy to use, very, very easy to use. So what you just need, I think, a little bit of tutorials online will help you get you going applying these tools. So you mustn't be a programmer before you can analyze your data. Yeah.
Thank you very much.
And there are still a few more people raising their hands, but unfortunately, I think we'll just take the last one and then we'll maybe try and get in touch, arrange for a way they could get in touch with you, Engineer Chinedu, if that's okay, to ask any further questions. So the last one we'll be taking is from Tonbra Allen. Please, can you unmute yourself and ask your question?
Yeah, good evening, everybody from Nigeria. Thank you, Engineer Chinedu, for this webinar. In fact, can you hear me?
Yeah, clearly.
Yes, we can hear you.
Yes, some years back, I started a course on Coursera on machine learning, and somehow along the line, I'm a programmer, but somehow along the line, I got lost and I just threw it away. And some weeks ago, I received an email. They were inviting me for, to take the course. And just yesterday, I saw this email from the NSC, and I got excited about it. Now, this is the question. What's your advice for somebody who wants to go into, machine learning, mostly to deploy in the power industry? What do you think could be a starting point, as in packages that you need to, prerequisites that you need to start, working with before diving deeply into it? Thank you, Engineer Chinedu.
Okay, cool. Machine learning could be seen from different angles, basically. So most of my work is on machine learning, but there are two phases to it. So there is applied machine learning and philosophical machine learning. So applied machine learning means you just want to apply it just like what you say. You want to take it as a tool and apply it to a problem. Philosophical machine learning means you want to actually develop this algorithm by yourself. So depending on the direction you want to look at, okay, if you want to develop them, you need to have adequate mathematical background. You have to know your linear algebra very well. You have to know your calculus and vector calculus, basically. You have to know probability and some level of statistics to be able to do it. But if you don't want to know all these things, there are tools available to do it. I think one place to look at is actually some of these online courses, basically. You can learn a lot from them. But I think one of the reasons why you got lost, maybe the package you chose, the online course you chose, I may not be able to pin down one, but there are ones that are interested in people that want to apply, not people that want to solve the mathematics. Maybe you chose a machine learning course where they are solving a lot of mathematics and you're not interested in it. You want to start seeing something work, okay? In that case, maybe you have to scout for the ones that treat these things as black box model, telling you how to take them as a tool and applying them to your problem, okay? So that's what I would advise. And it's a good place to start. I think there are also books you can look for online that at high level that will show you how to apply them. Unless you're interested in the mathematics, you can have a lot of mathematical machine learning books out there, which I don't think that's what you want to do. Yeah.
Yeah,
I don't know
so
whether I
that's
answered that question.
Yep, I believe so.
Okay, so thank you very much, Engineer Chinedu. I think there are still some other questions on the chat, but what I've said is we'll try and get, if you can drop your contact details and questions on the chat box, and then we'll try and arrange for that to be sent to Engineer Chinedu, if that's okay with you, and so that you can try and get back in contact with them. So thank you so much, and I'll hand over back to Dr. Emmanuel.